Welcome back to the deep dive. So today we're tackling something a little different, a bit unusual for us. We have this highly technical spec sheet for a piece of broadcast hardware. It's the Thor Broadcast H-HDPerformux-8 encoder. And our mission really is to figure out how this one little box can act as a head-end replacement for distributing video. And that's the key term, isn't it? Head-end. This is the machine that basically solves a huge logistics problem for broadcasters. It sounds like, deep infrastructure jargon, but what you're really looking at is the thing that clears the bottleneck. It takes all your pristine video sources, in this case 8 separate HDMI feeds, and it converts that massive amount of data into network streams that you can actually distribute into IPTV. Okay, let's unpack that a bit. Looking at the base model here, the HDTVSupply, high density seems to be the whole point.
Yeah.
It handles 8 HDMI inputs from the get-go, and you can even get chassis options that go up to 24.
Right.
And pushes all of that out through a single gigabit network connection. It's using standard protocols like UDP, RTP, and the encoding is H.264.
And that ability to consolidate is precisely why it earns that head-end replacement title. I mean, you have to think about what a head-end used to be. We're talking huge racks of gear, satellite receivers, demodulators, all needing a ton of power and cooling.
So this is replacing an entire room of equipment.
An entire room, yeah. This is a single 1RU device. So for system operators, the savings on real estate and power are they're immense.
That alone is a huge return on investment. And it's clearly not just a simple converter box. It has to fit into these really complex systems, right?
Exactly. And for the operators, a really practical feature is that single ASI output. It basically just mirrors the main network stream, the MPTS. That little detail makes it so much easier to integrate with older, specialized gear they might still have.
Okay, and this is where I found it gets really interesting, where you see it's truly built for, professional cable distribution. This box is doing some pretty sophisticated stuff inside. It does PID remapping, and it says here up to 180 output PIDs per channel.
Which is critical.
And it also handles PCR adjusting. These terms get thrown around, but what do they actually do?
Well, they're all about stability. PID remapping basically keeps all the different video and audio streams from getting mixed up and confusing the decoder on the other end. And PCR adjusting is for timing. It makes sure your audio and video are perfectly synchronized. Without it, you get that horrible lip sync drift. And then you have those other features like inserting QR codes or logos. That's often a contractual thing for cable operators, a compliance mandate.
So that's the H.264 model. It's the workhorse. But it sounds like it has an efficiency ceiling, especially if you're trying to push 24 feeds, which I assume brings us to the Plus model. What problem is that one trying to solve?
This is where the whole bandwidth equation just completely changes. It's because of the shift to H.265 HEVC encoding. So if H.264 is like a reliable moving truck, H.265 is a hyper-optimized container ship. This encoding standard can save operators up to 75% of the bandwidth compared to the base model.
75%. Hold on. That's a staggering number. It completely changes the economics. But if the savings are that dramatic, why even make the H.264 model anymore? Why would customers still buy it? What's the catch?
That's an excellent question, and it really just boils down to two things: legacy systems and cost. Think about it. Upgrading an entire network of decoders and all the back-end infrastructure to support H.265 is a massive expense. So a lot of organizations, they still rely on the established, cheaper H.264 standard because it works with all the older receivers they already have out in the field.
That makes perfect sense. Compatibility is king. And the Plus model wasn't just about the new encoding, was it? There were quality boosts, too. I'm seeing it supports resolutions up to 1080p at 60 frames per second. That's a big jump from 1080p 30.
And it's crucial for things like live sports. Anything with fast motion, it just lets you capture that energy without the blur. Plus, they expanded the audio options quite a bit. You get different flavors of AAC and even AC3 pass-through. And they added the RTSP protocol, which just gives you more flexibility for streaming and integration. It's really about future-proofing.
So to wrap this up, what this all means for you is that this one little 1RU box, and the base 8-channel model starts at under $4,000, is really the backbone of modern video distribution. It's all about using network protocols like UDP and RTP to move just massive amounts of video data efficiently.
And considering that incredible 75% bandwidth saving you get from H.265 HEVC, it leaves you with a really interesting question to think about. How much more content could our modern infrastructure actually distribute if every single one of these professional encoders made that leap? And what would that do to the cost of streaming video around the world? That kind of efficiency suggests the whole cost structure of video delivery could be Well, poised for a fundamental change.